Alright, at this point, you have learned how to prioritize groups around a chiral carbon and also learn how to assign R and S, whether that lowest priority is a dash, wedge, or line. Let's push the envelope a little bit, and instead of looking at molecules that are drawn like this, where it's clearly tetrahedral, um, we are going to look at examples where we have to determine the RS chirality of carbons that are on Newman projections and chairs. So it's a little bit more challenging. And let me show you an example. The first example is, let's take a Newman projection. Okay. And we have the front carbon, which is a dot. And I'm going to situate my 3 bonds in the front like this with an OH, CH3, and a Br. The carbon in the back, is drawn as a circle. And I'm going to make this staggered so it's a little bit easier to read, but we'll do an eclipse probably for the next example. And in the back, we have an HH, and let me put a chlorine here. Okay. It may not be apparent that this molecule is chiral because we do have a chiral carbon and it's the front carbon. See, that carbon has 4 different paths or 4 different groups, a bromine, a methyl, an OH, and when we go to the back, it's a carbon with a chlorine. Okay. Now, I cannot really work that well when I look at a Newman projection. I want to change my point of view. And my point of view is going to be changed, so I'm looking at it from the side. Okay. Now, what I want to do is I want to have the front carbon on my left, the back carbon on the right. So let's orient ourselves. What color am I going to use? Here's the front. Okay. I'm okay with assigning R and S when I see wedges and dashes. That's why I want to redraw it as carefully as possible to see wedges and dashes. From the stick figure's point of view, that OH is on the right, or that carbon in the front is on the right, and it's connected to an OH going up. Okay. Therefore, we are going to draw wedges and dashes, and that I believe we can assign fairly easily. But now we have to figure out where these 2 groups are, or what these 2 groups are. Okay. Before we fill in those, let me just show you with a model what I'm actually doing. What I'm actually doing is I have my molecule like that. Okay, do you see how the OH is on the top? Bromine blue, and methyl to the right. And we have the chlorine in the back to the right as well. What I'm doing is I'm standing right here where my index finger is and looking towards it. So now our new point of view is this. Okay, you're shifting the carbon or rotating carbon or the bond. So now, do you see how that front carbon is on the left? And then the OH is right there at the top. My question was, where is the bromine and the methyl group when you do that turn? Okay. If that was a little bit fast for your liking, go ahead and rewind the video. But when I turn that molecule, okay, so we have the same point of view as the stick figure, that methyl group is coming towards the stick figure. The methyl group is right here. And the bromine is over here. What's going on in the back carbon? The back carbon, which is this one, that back carbon is to that stick figure's right, to its right. So here we have the back carbon to the right, and we definitely have a hydrogen going straight down. That hydrogen is the line. Now, which one is the wedge and which one is the dash? See, the chlorine is closer to the stick figure, so as I rotated that bond, now this chlorine is coming towards us. just like it was coming towards the stick figure. And then we have a hydrogen here. Hopefully you can tell that this carbon right here is not a chiral carbon. Not a chiral carbon. Whoops. It doesn't have 4 different groups. But the front carbon for sure. So let's prioritize. Bromine is number 1. So we have oxygen versus the carbon here and the carbon here. So oxygen beats those 2 carbons. Now we have a CH3 versus the C connected to 2 H's and a chlorine. So this path to the right is higher or stronger priority than this methyl group. The methyl group here is the lowest priority. In the previous video, it was 0 to G50. I told you the trick if your lowest priority is a wedge. If 4 is a wedge, I said, tell this to yourself silently, it looks blank, but it's actually blank. Because the steering wheel is pointing in the, we're sitting in the wrong chair. We're actually looking from the windshield through the steering wheel column to the steering wheel. So from our point of view, 1, 2, and 3 looks R, correct? 1, 2, 3. It looks R, but we're looking at it from the wrong side. We want the lowest priority to be dash, so you take the opposite. It's actually S. So this is S. All right, and then if you need to restate it on the exam, I guess you could point to that carbon and say that that carbon stereochemistry is S, sinister. Or counterclockwise. See, I almost got tripped up. It looks clockwise, but because the lowest priority is pointing in the wrong direction, you take the opposite. Okay, let's try another Newman projection. And we have the front carbon. 80%, 90% of the time when I have a Newman projection, I go ahead and redraw it with the wedges and dashes. Now, there are some of you out there who can say, well, you know, this is the lowest priority. If I could figure that out without having to redraw it, if this is the lowest priority, then all I need to do is put my eyeball up here and look down this bond. Okay, but it gets a little bit hairy, at least when I do it. Sometimes I get a little bit confused about where everything is. Okay, I would rather redraw it. Next example, let me draw the dot and the circle. And on the dot, we are going to have, what are we going to have? We're going to have H. What did I draw here? H and CH3. Okay, it's apparent that the front carbon is not chiral. It's not a chiral carbon because it has 2 hydrogens. All right. What about the back carbon? The back carbon, I'm going to draw this as eclipsed, make it a little bit harder, but I think when we redraw it, you're going to realize that it's not that hard. Okay. It has a chlorine and a methyl group. Again, it doesn't really matter where you stand. I just want to redraw it from the side. I often like to stand to the right of the Newman, and as I look down it, this front carbon right here, that front carbon right there, will swing to the left, just like here, the front carbon swung to the left. Left to whose point of view? The stick figure's point of view. That's how I would do it. So the front, you could say, becomes the left carbon. Set up your bond, your carbon-carbon bond, and now you know that this is your front carbon. We have an H that goes straight up, and to fill in the rest of the bonds to make it look tetrahedral, you have 1 wedge and 1 dash. Okay. What is closer, this methyl group or this hydrogen to this person. It's the methyl group. Your CH3 is right here, and your H is right there. Again, the left carbon, or here we call it the front carbon, is not a chiral carbon. Let's take a look at the back carbon, which will become the carbon on the right. Now look at that H. That H is still going up, just like on the other side. So here, here we had it staggered, right? The bonds were staggered, but now here they are eclipsed. And the other two bonds on the right-hand side look like this. Now we have to decide where's the chlorine and where's the methyl group. This chlorine is closer to the stick figure. That's chlorine, and this is the methyl. Okay. Again, now we're making it a little bit harder. It was hard here because the lowest priority was not a dash, but we have the trick where you take the opposite. Here, oh boy, the lowest priority is neither a dash nor a line. It's this hydrogen right here. Neither a dash nor a wedge. It's a line. Chlorine is number 1. And then your last two groups, you have a methyl versus this carbon that's connected to another carbon. Therefore, this is 2 and this is 3. Okie dokie. In the previous video, again, we looked at some molecules that are not drawn very easily to pick R and S. And this is one of the cases where now the lowest priority is a line. In that previous video, 02G50, I said draw a stick figure that's going to be the driver so they could see the steering wheel properly. I'm going to draw, so here's my steering column. So I got to draw the point of view from this person driving. Okay, you could even think of it as this way, like that. You have a steering wheel. There's your steering wheel, and there's a person sitting in the driver's seat looking at the steering wheel. So the steering wheel has 3 prongs. Okay, let's go back to this view and let's try to predict. Okay, where are those prongs? From his point of view, they see this. Do you notice that this bond here, the 2 bond, is going to their feet? That's 2. Where is the 1 bond and where is the 3 bond from the stick figure's point of view? Well, this is chlorine is coming towards us. From their point of view, as they're looking up at the molecule, wouldn't that chlorine be on their left? Chlorine is priority number 1. Let's not clutter it up. Let's just put 1. Methyl group is to their right, upper right. You know, when you're driving, they tell you to put your hands at the 10 and 2 o'clock position. From their point of view, that is the 10 o'clock position. Okay, and the 10 o'clock position is priority number 1 in our case. That is in the 2 o'clock position. That's the 6 o'clock, right? It's going to their feet. All we have to do is now read this because we know that the lowest priority is to the back. Okay, and you could draw it like that. Oops. 4. 1, 2, 3. That is counterclockwise. This stereocenter right here is S. Okay, counterclockwise. 1, 2, 3. Yes. And then if you want to go back to the original drawing, make sure you're pointing to the correct carbon. The front carbon is not a chiral carbon. The back carbon is, and that is S. Okay, so another S. S and an S. Okay. The next example that I want to do is an example using a chair conformation. Okay. I know I'm drawing these kind of fast. If you want to test yourself, go ahead and pause the video and copy the drawing and go ahead and try to assign R and S. You know the rules. It's just a matter of these little tricks and visualizing where all the bonds are. I have to warn you, it kind of drives me mad when there are wedges and dashes on a chair conformation. So for chairs, no wedge or dash, please. You have axial up, axial down, equatorial up, equatorial down. And the molecule that I want to analyze their chirality for is this molecule here. Now, do you understand that this molecule is not chiral, the way that I have drawn it? It has no chiral carbons. Right? The path going down can go all the way around the ring. That person who walks that path will see the same exact things that the person who walks to the left will see, walking all the way around the ring. It's symmetrical, right? Symmetrical molecules are not chiral. How do I make this chiral? I have to make it asymmetrical. Okay, I like the idea that this carbon has a hydroxyl group and a methyl, but to make the two paths different, I'm going to put a bromine on this carbon right here. Definitely the path going to the left is going to be different than the path going down this bond right here. Okay. I'm going to advocate redrawing this. And how do I want to redraw this? I believe that you're good at assigning stereochemistry when you see wedges and dashes. And that's why for the Newman projection, if you can do this properly, the redrawing, I would do it that way. Okay, so you can see wedges and dashes. Well, where do these chair conformations come from? Remember in your problems where you have to convert a flat drawing into a chair? Let's go the backwards. Let's convert a chair into a flat cyclohexane. Now this is, you got to be super, super careful because depending on how you rotate the molecule, you could totally miss where the two bromines are. Okay, this is how I want us to rotate it. And then we'll come back to the drawing after we look at this model. Now the way that I want us to rotate this is, first of all, that is the chair that we had, the OH going straight up, and the two bromines on this back carbon, carbon number 5. Okay, I'm about to move the chair. Look very carefully how I'm going to do it. I'm going to rotate and twist like that. Make a mental note. Where are the two bromines? Okay, where are the two bromines? Are they on the left or on the right? Okay, make a mental note that that hydroxyl group is wedge. So I started like this. Okay, that's the drawing I have, and I'll flip over the page in just a sec. And what am I doing? I'm actually looking at it from the top, right there. So as I rotate this like that, now I'm looking at it from the top. Okay. Where are the two bromines? How is the OH now? Wedge or dash? Before I forget, the two bromines were on the right. And it's unnecessary to draw wedges and dashes because this carbon right here is not a chiral carbon. Okay. And what do we notice about the OH with the movement that I made? The OH is wedge. Okay. Oh, I thought we had a hydrogen here. We have a methyl group. You can't forget that. That methyl group now has to be, by default, dash. If you're confident in redrawing it flat, then I think you have a better chance of assigning this RNS than the actual chair. This carbon is chiral now, okay, because the molecule is not symmetrical, unlike this one up here. Prioritize. Carbon, oh, not carbon. Priority number 1. Okay, let's practice, because now we have a carbon versus a carbon versus a carbon. But I could hear some of you say that you know that this CH3 is definitely lower priority than these two, because these two keep going and they are attached to another carbon. This is lowest priority. Now this is a CH2, this is a CH2, okay? So you tell the two stick figures to keep walking. Now you're comparing this carbon to this carbon. And then obviously this carbon with the two bromines on it has a higher priority than this carbon here. That technique is called playing cards, or I call it playing cards, and that is in a video 0 to F50, 2 videos before this, where we learned about the Kahn-Ingold-Prelog rules. Anyway, finally, we have a drawing where the lowest priority is dash. All we need to do is read where 1, 2, and 3 are. 1 to 2 to 3, that is counterclockwise. We flipped the coin 3 times, and we got S for a third time. So for our 3 examples, 2 that are Newman projections and 1 that is a chair, that carbon is also S. Okay. I think I have time for one more, and I am going to give you this one. And I want you to pause the video and figure out whether this molecule is R, S, or achiral, neither. Okay? I'm not going to say anything else. When you unpause the video, be ready to say whether you have R or S or neither. Okay, I'm back. I'm going to do the same movement as I did before to get the ring to look flat to me. Now that O, I'm going to consider atom number 1. Okay. So where is the potential chiral carbon? It's on carbon number 3, and it is now to the right. If you remember, carbon number 5 for us was to the left. Now when I look, you could almost say, look at it from, this is another way to draw an eyeball, like that. If I'm looking at it from the top, then that H right here is closer to my eyeball. And this NH2 is further away from my eyeball. There is your tetrahedral carbon. That's lowest priority. Nitrogen beats the both carbons. And then we have carbon versus carbon, but this carbon up here is connected to an oxygen. Priority number 2, priority number 3. It looks 1 to 2 to 3, it looks S, but your lowest priority is wedge. We are doing the trick where you say if lowest priority is wedge, it looks blank, but it's actually blank. The lowest priority is wedge. It looks S, but it's actually R, and it's that carbon, that's the chiral carbon, and we're going to assign it R for the greater. Good. 2 examples of Newman projections, 2 examples of chair conformations assigning R and S. All right, good luck all. And if you are in my class, if you have any questions, feel free to email me.